Welcome back. So last time we looked at studies suggesting that nurturing parenting compensated for a child's genetic predisposition towards unhappiness. But you may remember from last week's lectures that this is in the context of a lot of studies that have followed twins throughout life as they were raised by separate families. And these studies show that twins continue to have many similarities, even if they'd never met. Well, a study of 80 pairs of identical twins showed that 50-year-old twins had over 3 times the epigenetic differences of 3-year-old twins. Twins who have spent their lives apart, such as those raised by different families, were most different in their methylation patterns, showing that methylation markers change as we get older and experience different environments. Well, the idea is that the environment plays a key role in shaping our epigenome, which in turn influences the activity of our genes, which in turn may shape our behaviour, lifestyle choices and health, which in turn changes our epigenetic profile, and so it goes on. Our epigenetic profiles mimic our individual life stories and may be as unique as we are. However, IQ and personality become more alike as twins age. So what do we make of this? Science may be showing us that many personality traits are somewhat set, for good or bad, from birth. But a nurturing environment can rewrite some genetics in some people because we have lots of genes that react to the environment. Well, that may sound a bit depressing if you do not get a nurturing environment. However, insofar as your outlook on life is determined by epigenetics, things may not be set in stone. If high-stress rats were put in a low-stress environment as adults, their epigenetic markers still manage to change a bit, resulting in a more low-stress animal. Also, like rats, you can have some self-awareness. Perhaps you can change your behaviour if you really, really try. You can choose to be attentive, even if your parents never were. And in reality, how important is it to be calm and controlled in response to stress? What would happen if one of those calm, happy rats were to stumble upon a cat? Be less concerned about danger, be more likely to die, whereas an anxious rat will be on its guard and could better survive the hostile environment. So, through her licking, or lack of it, a rat is writing information on her pup's DNA that tells her pup something about their world and makes them more likely to succeed. Likewise, it might be beneficial to human children too to know whether the world says yes to them and is a friendly place, or it says no to them and is wise to be anxious. People born into a war-ridden society have an inactive cortisol receptor gene and thus a guarded and anxious personality. Don't you think that could be advantageous for survival? So it seems our resilience to stress may be determined by our genetics, environment and upbringing in a way that has been selected to be adaptive. Now, the relative contributions of genetics, environment and upbringing are going to be very hard to predict, as there are few shared family effects and these go in every direction. The studies I mentioned last week, which showed that the effects of parenting have been exaggerated, also confirmed a correlation between parental handling of adolescence, be it harsh, lax, loving or indifferent, and later adolescent behaviour. However, they found this was mostly due to the genes shared by the mother and child. These as yet unidentified genes accounted both for most of the mother's behaviour to the children and any subsequent antisocial behaviour by those children. In fact, studies suggest that it is not so much the parent who influences the child, but the child's genes that influence the parent's response. Parents react to the child more often than the child reacts to the parents. It's also likely that when the parent-child bond goes wrong, then this itself will lead to bad alterations in the epigenetics of genes controlling the behaviour and emotional state of both the mother and the child. Well, that brings us to intervention programs like the Nurse Family Partnership, the NFP, designed to provide parental advice to high-risk failing families in America. Well, trained nurses visit mothers at least twice a month and they offer advice and assistance. The results have been excellent. NFP-trained mothers were 4 times less likely to neglect or abuse their children, and the nurse-visited children had 50% fewer arrests and significantly lower use of drugs and alcohol. And it's extremely cost-effective. So similar programs are being set up all over the world. But don't these successes also seem to contradict the genetic studies showing little influence of parenting? Well, twin studies that show antisocial behaviour in young people linked to early environment also show them losing that behaviour as they get older and finding a new environment. People pick an environment that suits them given half a chance, and the environment that suits you may be in large part determined by your genes. Well, experts say that some of the NFP's success comes from improving the social and economic situation of the family and the mother's ability to cope with problems. But the experts also believe that changing the destructive relationship between the mother and child is key. So basically, we're talking about teaching the parents to understand the child's needs, and presumably, therefore, the child's genes. Well, as we've seen, kids with certain forms of neurotransmitter gene alleles are more likely to be resistant to change, whatever the environment, no matter how bad, where some kids react in an extreme way, both good and bad, and these results could involve epigenetic changes. Well, the implication in this way of looking at things is it might be better being one of the kids who is less susceptible to the environment. However, in 2011, Jay Belsky and Kevin Beaver proposed a change in perspective. Based on studies on American teens, they proposed that these neurotransmitter alleles be thought of as plasticity genes rather than vulnerability genes. This means that if the worst behaving kids in a bad environment, those we predict to have the low-activity monoamine oxidase allele, the short serotonin transporter and the like, if they were put in an ideal environment, they might actually rise above the less plastic kids in terms of social skills and IQ. Well, this hasn't yet been proven, but it must be the best hope of the NFP and other intervention programs. Let's go back now to something I talked about last week. Irrespective of parents, there's a lot of evidence that the environment's chief influence on the personality of most children is through their peer group. Judith Harris wrote a very famous article on the subject back in 1997. She suggested that ancestral human beings reared their children in groups, so the natural habitat of the child was a mixed nursery. A nursery of children of various ages who probably segregated themselves by sex, as they still do. Children, therefore, don't see themselves as apprentice adults. They're not copying adults. They're trying hard to be effective and well-liked children, which means finding a niche within groups of peers, conforming but also differentiating themselves. A lot of work has suggested that children from the age of 8 specialise, and that this is genetically determined instinct. They want to be special. To this end, a child will try out roles and find one he or she is good at. He'll become the wit, the scholar, the tough. The evolutionary psychologist Frank Soloway sees each child within the family as selecting a vacant niche. If the oldest child is responsible, the second child will become a rebel. Even amongst twins, small differences in innate character are exaggerated by practice. There's the famous and sad case of Layden and Lala. They're Siamese twins. They were conjoined at the head. And of course the two girls did everything together, eating, playing, sleeping, because they could never leave each other's side. Well, despite their identical genes and environment, Layden liked animals, while Lala liked computer games. Layden was the talkative extrovert, while Layla was shy. They died during surgery to separate them. They got into that surgery knowing that death was very likely, but they wanted lives as separate people. Tim Spector calls it the built-in individuality processor that works all our lives to make us more different than our companions. It's a tendency for human beings to distinguish themselves from their closest companions by building on innate propensities. So if others are practical, it pays to be cerebral. And perhaps epigenetic mechanisms are part of making us more unpredictable and help us develop the individuality that's such a priority to us all. That would be very hard to test. Ideally, you'd like to take a batch of human clones and rear them all identically and see how their behaviour and epigenomes turn out. You can't do that with people, but you can with mice. Now, mice aren't a perfect model because as far as we know, they don't have an individuality processor. Mice aren't trying to be different from each other. But it turns out that they do end up different. In one experiment published in Science in 2013, 40 genetically identical mice spent 3 months together living in a 5-story cage with lots of toys. Well, at first these genetically identical mice behaved the same, but over time they began to have different behaviour patterns. Tiny initial differences in the activity of a mouse, which could be due to chance, might lead to an enjoyable time with a toy, or meetings with other mice, which might in turn fuel a desire for more adventures. Some mice ended up a lot more adventurous than others, and these grew additional neurons in their hippocampus, which remember is a brain region linked to learning and memory. Epigenetics is the prime candidate for explaining these results. Tiny epigenetic differences change gene activity, which in turn sculpts interactions with the environment, which then feeds back to the epigenome, amplifying the message, which further influences gene expression, shaping behaviour and how we experience the world. So, I just used the word chance. Does chance as well as genes and environment contribute to our individuality? Unpredictability may be built into epigenetics. I mentioned that the epigenome of identical twins diverge over the years, and this is attributed to the environment. Something weird recently discovered is that identical twins who share the same genes and womb can have epigenetic differences even before they're born. Well, how can that be due to the environment? They share the same womb at the same time. Well, epigenetic variations could initially arise randomly or from small physical differences in the womb. Perhaps one twin has a bigger umbilical cord, for example. But Andrew Feinberg at Johns Hopkins University believes that random methylation events are built into our systems as an evolved feature, and that there are hundreds of regions of our genomes where methylation patterns are neither genetically determined nor set by the environment. They happen by chance. And these random epigenetic changes produce more variation in genetically similar offspring, increasing the chances that some of them at least will survive. What this suggests is that many aspects of our bodies and behaviours are the result of complex interactions between genes and environment, mediated by epigenetics and with a large dash of chance thrown in. Which once again goes to show how pointless it is to talk about nature versus nurture.